So Dirichlet function yesterday I told, and I will do this by UPF LPF concept. So just for knowledge, huh? No need to, you want practice, you can see book and can practice, but don't do, no problem, no need. And but exam hall asking one question CSIR and CSIR and BHM. Okay, so how to find that short trick we will see. But short trick that is just trick type only, means 90% success, 10% 90% enough for us. Because CSIR, what we'll ask, no, that from that 90% only we'll ask, because CSIR also don't want to give you any problem extra, because UPF LPF method is not for competitive exam, more lengthy process. So first the we will do partition of closed interval 0, 1, generalized partition I will write. Suppose you are going with P1, P2, P3 partition. You see P2 means 2 by 2 will happen, 0, 1 by 2, 2 by 2. Third time going means 0, 1 by 3, 2 by 3, 3 by 3. So generalized partition I have to do work on ith sub intervals. Xi minus 1, Xi is this. So UPF, LPF, we want capital MI and small mi. This ith interval, supremum and infimum on this subinterval. So function whatever define have, function two type define have. So both places the supremum infimum you put. Okay. Supremum, infimum always changeable, not a fix. Depend on function and depend on subintervals, and maybe in between any points also supremum, infimum possibility. But if at least one supremum, infimum, you are feeling one supremum, infimum, not Riemann integration coming, UPF, LPF not equal coming, miss finish. That is not a Riemann integration. Okay. So still supremum, infimum not deciding, because function x and minus x. So mostly x and minus x on supremum, infimum, direct x place we put supremum. Here also supremum I put this, infimum both places I put. Hereafter you have to decide out of these four values who is the supremum and who will be the infimum. Means capital Mi and small mi. So this is confirm have that capital Mi will be I by n. Suppose you want to compare with any subintervals P1, P2 first partition, second partition, third partition, by that also you can find it. Okay. The supremum, infimum finding only always confusion. You have practiced properly, you can do, otherwise can't do. Okay. what I was thinking, you can compare this who is the supremum infimum by any subinterval. So I giving confusion, then you can choose your subinterval 1 by n, 2 by n, or 2 by n to 3 by n, and anything. So I will be 2. If 2 by n I will choose, means I will be 2. So I will be 2 means 2 minus 1 by n. So this is your 1 by n to 2 by n. Okay, if I equal to 3 can choose, or 4 can choose anything. How many partition you are doing, and also 2 is 2 by 2, 1 itself will come, 3 by 3 means 1 itself will come. So and you leave it, no, don't put. So if I is equal to 2 I am choosing, then you see here this will be the 2 by n, this will be the minus 2 by n, this will be the 1 by n, and this will be the minus 1 by n. 2 minus 1, minus 1 by n. Morning itself mind not working. Minus 1 by n, huh? So who will be the very less? This positive no need to think. Positive supremum will come must. So minus 2 by n and minus 1 by n. Who will be the less? Suppose n equal to 2 choose. Then this will come minus 1. This will come minus 1 by 2. Who will be the greatest or less? Less one, because infimum we want. Minus 2 by n. Finish. Understood? Supremum infimum of f of x. If suppose this function is x square minus x square, so every place is square will come, because we have to choose supremum of f of x and infimum of f of x on this subinterval. Okay, again like that compare we will do who is the very highest, that will be the supremum, who is the very lowest, that will be the infimum. Okay, then finish capital Mi small mi came, so we will find UPF and LPF. First this n can take common outside, so n square will come outside. So I think summation I only coming, and summation I meaning till nth term addition. So summation n will be n into n plus 1 by 2 minus 1 not. So okay, later this is a sequence form, so later we will solve. Okay, I told UPF LPF always sequence form will come. Okay, next LPF we will do. Same 1 by n square outside, minus also can take outside. So UPF LPF both coming sequence form. After that I have no place, you write first. Just here after to apply, both are convergent and limit points are equal, then Riemann integration. Not equal, then not Riemann integration. And the limit point of this will be the upper Riemann integrable value. This will be the lower Riemann integrable value. Right. Just for knowledge, you can practice from your BSc MSc book, UPF, LPF. Just some question practiced. Exam purpose, no need. And if you can find that supremum, infimum correctly, then no problem after that. So you can see that upper Riemann integration 1 by 2 coming, lower Riemann integration minus 1 by 2 coming. So both are not equal. So function is not Riemann integration. Okay. Finished. Understood everybody? So for knowledge purpose, you can practice like that UPF, LPF, huh? Otherwise no need. But exam, CSR exam, no that much not giving any function type or anything. Very normally function will give and will ask this is Riemann or not. This type function only will be not Riemann, but Lebesgue integrable will happen. Lebesgue integrable we will see, means we won't read. One short trick I will give later. Okay, because that is coming from measurable set. That is not in our syllabus. But Lebesgue, this question only will ask Riemann or not. Okay, not Riemann. Second option, Lebesgue or not. Just one line. Means unnecessary question can tell. But we have some trick and all, by that direct we will take out. Can tell also every Dirichlet functions are Lebesgue integrable. Okay, so no problem. We will see. That trick we will see last. So if CS are asking like that, anything giving x minus x, x square minus x square, anything giving, direct what you will do is both functions separate integration on that interval. Okay, separate integration to must never equal will come, not equal. So this function is not Riemann integration. Equal never will come, any Dirichlet function. But this is a trick only. In this trick only, no 100% guarantee I am not giving. Otherwise, with concepts, more tricks and all we are seeing. I saw BSMSC books, more Dirichlet function I solved. In that I saw like that also some function not equal to have, but Riemann integration. So this is a trick, not a concept. In any interviews and all going on, don't start this type. They will tell throw outside, go outside. Okay, just for CSIR exam purpose. We have no time on exam hall, UPF, LPF we will do. So if asking like that, just you do separate. Who will be the value? This will be the UPF, but telling upper Riemann integration. This will be the lower Riemann integration. Just supremum, infimum, we will see. In the out of two value, who is the greatest value that you think UPF value, lowest value will be the lower Riemann integration. Maybe they will ask UPF, LPF value. Upper Riemann integrable value, lower Riemann integrable value, separate integration do, and you can take out. But not a guarantee always. Okay, if they will tell if this type value not equal coming with function is not Riemann integration, not like that. Some functions are there. You will see that not equal coming by short trick, but that is Riemann integration by UPF LPF method. So this is just short trick. On exam hall coming, you do like this. If both are equal means Riemann integration tell, not equal means not Riemann integration you tell. Okay. Any type of function they can give. But I will tell if possible your practice time this is UPF LPF try. Okay, don't depend on trick. This is only for exam purpose. You also search that which place this trick fail going. Okay. Any interval you can choose, but mostly always I saw they are giving close interval 0,1 because close interval 0,1 partition is very easy. Generalized partition. Suppose you can't do generalized partition, then you can go by P1, P2, P3, like that 3-4 partition you can go. And for every partition, UPF, LPF find. And after that generalized you can prepare. UPF generalization, LPF generalization. Okay. Any problem? After we will see fundamental theorem of Riemann integration. Letter write, what writing? Aprama. Okay. Hereafter we will see fundamental theorem of Riemann integration. What is this fundamental theorem? Very conceptual topic. This is exam hall not coming. Interviews coming. If you will go for interview for in real analysis, they will ask question this. What is the fundamental concept of Riemann integration? You have remember in 11th class, 12th class, integration chapter 2 types. What is that name? 2 chapter name no in 11th class, 12th class book. Infinite integration and definite integration. Correct. Which books you read in your life? Don't know name and all. Correct, I'm telling Anna. 11, 12 pass or not? TTMP. Turn to geometric pass. Pass only or what? Pass. So how you passed? You don't know chapter name? 2 integration of calculus. That time books name are calculus. Some places differential calculus writing. So in that 2 chapter have integration. First chapter will be indefinite integration writing, and after indefinite finishing is definite integration writing. Correct? Indefinite integration, no limit there, upper limit, lower limit, not definite integration means upper limit, lower limit writing. Correct? That also forget. Everything forget. What is the integration of this? Very good. X square by 2 plus C. Correct. Why giving this plus C? Constant. Integration. Integrating constant. Why? I won't give. Any problem? What problem? I won't differentiate. This only answer everybody telling. I won't differentiate. Why differentiation what? Differentiation what will happen?
Sir, it is not accurate solution.
X only will come. 2 cancel X. Same function will come. Why won't get? Why won't get? Getting only our function is X. X getting no. Differentiate we will do. 2x by 2 will come. X getting. This only function, no differentiation and integration both are inversely proportional, inverse to each other. Proportional, not inverse to each other.
Sir, it is not accurate solution.
What is that exact? That's what where you are telling, not telling. What somebody telling something?
It is not accurate solution, sir.
This answer and all not acceptable, ma. Integration. Indefinite.
The x plus 2 the whole square is there means if you are expanding that then taking integration it is not equal. As it is if you are doing x plus 2 the whole square means by integration we have taken lesson the whole square once we expand and do it then both answers not getting same, sir.
This much big explanation giving I can't understand also.
Oh my god.
Slowly,
No sir. X plus 2 the whole square.
Then what you will do?
Oh.
I don't want 10. No, we are teaching no 10 child, no child 10 class, 11 class. Anything tell. Okay. Child time, anything telling no problem. But now I am not child, you are not child. We are research on research. First, we don't know that integration, indefinite integration, definite integration given by Riemann only. This also we don't know. That time. Huh? Riemann telling that integration function is integration always on closed and bounded interval AB. Where is it bounded? Any limit not have no? Then this is not correct. Then indefinite integration why coming? Not that is wrong. No indefinite integration in this world. Only definite integration only possible. Any a to b, 0 to 1 or anything. This wrong. Correct. Not correct. Then explain. No, can't choose. 0 to infinity, you will choose that will go improper integral. That is not a Riemann integral. If 0 to infinity can choose, then why reading Riemann integration? From yesterday, don't read. Sir, you are telling wrong, closed interval AB. You are giving a to infinity also possible. Then yesterday you have to do objection. Sir, I have objection. What? 0 to infinity also possible. Why only closed interval AB? This concept only we will see in fundamental theorem of integration. Okay. Why this constant giving? More statement telling you are correct also, wrong also, I don't know. But I can't accept that and all. I want exact concept. Okay. So fundamental theorem of Riemann integration, another name is indefinite integration. Another name is generalized integration. Okay. Why this name and all have, we will see. Riemann telling that our function Riemann possible on closed interval AB. After that, whatever verification have UPF, LPF method and all, we have to verify upper Riemann, lower Riemann, both will be equal. Then function is Riemann integration on interval AB. Fundamental theorem telling that we are choosing function our Riemann integration have on closed interval AB. Okay. When function is Riemann integration on closed interval AB, then any type of subintervals I will choose from this interval, then function is Riemann integration on every subinterval of closed interval AB. Correct? So that subinterval only notation here I am writing a to x, x belongs to closed interval AB. This is a to x means suppose 0 to 1 have means 0 to any x or x to 1. Anything we can choose. X belongs to closed interval. Don't think a already I am using here, so why a x will means a to a will happen. That type no need to think. So when function will be Riemann integration on every subinterval of closed interval AB, then how to give notation for generalized integration? So for every subinterval generalized only x we are choosing. Means x we can choose any elements from closed interval AB and we can integrate, that is. Suppose 0 to 1 have 0 to 1 by 2, 0 to 1 by 3, 0 to 1 by 4, 0 to 1 by 5, 0 to 1 by 10, 0 to 1 by 1 lakh, 0 to 1 by 1 crore, 1 by 1 lakh to 1 lakh, 1 crore to 1 by 100 crore to 1. Like that, every subinterval function will be Riemann integration. Okay, so that generalized integration, how to give the notation? So this is the our generalized integration. Meaning our given function is Riemann on every subinterval a to x. X is any value from interval a. This is called generalized integration. After that, what writing that this integration have to exist. Generalized integration, every function won't exist. Indefinite integration for every function not possible. Not possible. This function generalized integration possible? Possible. Possible. With limit possible. With limit possible means that is not a generalized. That is our part foundation. Definite integration. So this function integration only possibility when I will give any foundation. -1 to 1, -2 to 2, -3 to 3. So this function generalized integration not possible. For that, especially here writing after interval choosing generalized subinterval. So this have to exist. This integration have to exist. If does not exist, that means we can't go next. We can't count on indefinite integration that function. This function indefinite integration not possible. This is the Riemann integration, but we want must limit. This won't come under fundamental theorem of Riemann integration. This you can't write any integration plus constant. You can't write any function plus constant. I can't give this notation. So every function won't come under fundamental theorem of integration, generalized integration, indefinite integration. Okay. So which function Riemann integration have on? Understand theorem. Function Riemann integration have on closed interval AB. So function when Riemann integration have on closed interval AB, then function will be Riemann integration on every subinterval. Every subinterval of closed interval AB. And subinterval like this. X to B also you can write. This is not a fix. Don't prepare yourself anything. Every subinterval Riemann integration possible. But hereafter when I am preparing generalized, every subinterval separate you are doing. But I am preparing generalized integration possible or not. So generalized integration possible when exist a to x. This have to exist. Means integration will exist. So when this will exist, then after solving, this will be the function of x. This will be the function of x. You are telling now x dx, x is square by 2 plus c I dot. What is that c? That c notation only you tell only one thing. That is notation for indefinite integration. That is the notation for generalized integration, no other anything. Finish. No need any other explanation. More explanation have high level interview giving, explain start fundamental theorem of Riemann integration. If child also teaching 11 class child, 12 class child, 10 class, only tell generalized integration. No need to teach next. Child also confused. Differentiation why have to do? Why differentiation have to do? How to do differentiation of integration here? That time our mind not that any develop, anything telling we are accepting. Differentiation also no need to tell. Differentiation if you will tell no, then you have to explain about Leibniz theorem. Otherwise anything telling, anything they are accepting is anything don't tell. You see that plus c how coming here after. So a to x dt, when we will solve, this will exist and our this will be the depend on x I dot function of x, meaning this will be the any function of x. Okay, you see I wrote also this notation, both are same. This meaning here hiding have, we can't see that integration, but their limit have, but generalized limit is there. You see here integration t I am writing now t dt, and my interval will be 1 to, suppose 2, you are thinking 1 to 2 have, so I wrote here 1 to x from any points or any closed interval a b, then a to something, a to b, then here will come a to x. Hereafter if this integration I will do t square by 2, then a to x will come, then what will happen, x square by 2 plus a square by 2, and this a square by 2 only our c. We have no limit here, so any plus c constant we put, that plus c must will come, must that plus c will come. Don't give any type of unnecessary reason. That plus c what, generalized integration. This function is Riemann integration on any closed interval ab, so that c is any a square by 2. What is the value of c? A square by 2. Finish. Understanding? So this c value is any a square by 2, any constant. That is 1, 2, 3, 4, anything. We don't know. We here hiding have limit. So plus c, any constant, that is Riemann integration constant. Integrating constant we are telling. That integrate, if suppose more you wanted to tell anything good type in your mind, you tell that is our Riemann fundamental theorem of concept, fundamental theorem of integration. From there that integrating constant coming. That integrating constant is showing generalized integration. Our given function is Riemann integration on any subinterval of closed interval ab. Greatest integer function generalized integration not possible. I can't give any notation. Here must I want boundation, supremum, infimum, upper limit and lower limit. Finite want, not generalized. Okay. If this does not exist have, then generalized integration not possible. And this exists means this is the function of x, and this function here after this is also this only concept that our integration and differentiation both are inverse to each other. Because of this function here after derivative we will do, then f of x we will get. Okay, I will show you it. I wrote here also function must be f of x must be differentiable on closed interval a. So if derivative we will do, and this derivative using Leibniz theorem. Inside will go, partial derivative will change. After that, upper limit derivative and whatever function given have, in that t place x have to apply. After that, lower limit derivative. Again, same t place, lower limit we have to apply. This is the direct I will do. This is the partial derivative with respect to x. This is the t function 0. This is the 1 into f of x, and that also 0. So our f plus x will be f of x. When our 11 12 class we are not giving notation for limit, so direct f plus x is equal to this fx, that only, limit not have. So direct partial derivative and x, f of x. Not like that c have derivative will do, c will be 0, so fx coming. This type reason don't give. So okay, here integration plus c will come, so derivative we will do, so this will come 0, so this is fx coming. This is not a region. Understood? So C only one thing notation. C only notation for indefinite integration. C only notation for generalized integration. Because we don't know what is our closed interval AB. Closed interval AB we will choose, and A to x, that A is square by 2 or whatever function, A cube by 2, A power 4 by 2, that only our constant. Either lower limit or upper limit, and even x to b. Miss can tell that C is notation for total area. Integration either area of curves also telling. You told a region of curve, something she told her. That also correct as a statement. We don't know region where is starting, where finishing. So that is 1 plus C constant region that will only will come. Okay. I have no place. I have to write next. You write first. Google का here plus C, right everybody, huh? This A will solve, then C, that is. We'll solve, for that C coming. That only writing. You have to write plus C with integration only. This is only correct. After integration, not. When indefinite integration is started without limit, plus C start from there itself. Because this C will define this A or B. Otherwise, that is not a complete definition. Sometimes they are asking, not finished. Sometimes they will ask this. This is called a primitive function, capital F of x. Means integration a to x f of t dt is called a primitive function. So this primitive function, they won't give maybe this notation. We'll ask about this direct. So this primitive function is a uniformly continuous function or not on closed interval a b. True or false? True. Why? Little louder. Stand this. Stand. Don't put loudly. Tell. Tired? Anything? Loudly tell. I will come back. Tell. Leibniz function for uniformly. When I gave. That is Lipschitz condition I gave. Leibniz. You are tired. Maybe night sleep not coming. Reading maybe full night. Another anybody?
Sir,
Ha.
fx is differentiable on closed AB.
Again tell.
Fx is differentiable on closed AB, so it is continuous on closed AB, so it is uniformly continuous on closed AB.
Okay. He's telling correct. So Lemma. Won't tell. Correct. Pradnya also correct. You are also correct. This function I wrote here, differentiable on closed interval A. Differentiable on closed interval AB means must continuous on closed interval AB, and continuous on closed interval AB means must uniformly continuous on closed interval AB. Okay, so they will ask, they asked already, primitive function must be uniformly continuous function on whatever interval they will give on closed interval AB. Hereafter some question and all we will see some formula based question have. And one yesterday I gave like that one have, we will see. This type question also coming. So can you tell about this Riemann integration or not? N equal to 0, 1 to whole number. This is Riemann integration. How to verify? Countable number. Who is that? Discontinuity points tell. First function you define properly. Here this function is continuous, discontinuous. Discontinuous means what is the discontinuity points? 1 by 2 power n. What is the n value? Natural, 0 not. Correct. At 1 will be continuous. At 1 by 2 like the discontinuity will come. Because you see at equal to 1 functional value is 1. F of 1 is 1. And before 1 x less than 1, this meaning left hand side of 1. So at 1 LHL will exist 1. If suppose this function you are going to find continuity at 1, x tends to 1, f of x. So 1 we have only left side. So 1 minus we have to solve. Means LHL will exist or not. So this is the meaning. If suppose you are going formula and all using, otherwise direct also can tell left hand side function is 1 defining. So direct this will be the 1 value. Or if you will go formula as h tends to 0 f of 1 minus h, that also same only. F of 1 minus h is functional value at left hand side, left hand neighborhood of 1. So left hand neighborhood of function is 1. So LHL exists 1. What is the functional value? F of 1 is also 1. So both are equal. So this is the left hand continuity at x is equal to 1. This and all you have to find direct on exam hall. This much don't do. You have to check at 1 by 2 discontinuity. You can see at 1 by 2, x greater than 1 by 2 this is. Correct? So right hand side, x greater than 1 by 2 means 1 by 2 plus h. So right hand side will be 1, but functional value f of 1 by 2 is not 1. If you will go limit x tends to 1 by 2 greater than this is, so this meaning plus. So limit h tends to 0, f of 1 by 2 plus h. So what is the 1 by 2 plus h value? Is greater than 1 by 2 functional value? 1. So this is 1. But what is f of 1 by 2? At 1 by equal to have no. So at 1 by 2, 1 by 2. So not equal. So at 1 by 2 discontinuity. Understood? Like that, 1 by 2 square discontinuity, 1 by 2 cube discontinuity, like that will happen. One continuity will happen. This and all also asking on exam hall. Function is continuous on 1 by 2 power n. What is n? N is 0, 1, 2, dot, 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 or a natural number. Okay. So here, f of x is discontinuous at 1 by 2 power n for all n belongs to natural number respectively. Means n not equal to 0. Okay. So set of this sequence, what will happen? Sequence of discontinuity. This is countably infinite, can tell. Limit point also finite. S dash also 0. Finite limit point. Countably infinite also can tell. So given function must be Riemann integration on closed interval 0, 1. Okay. Understood. So if this is a Riemann integration, then what is the value of integration? Same type partition already function defined have. So you go 0 in lower limit have. Lower limit power will 1 by 2 to 1, 1, 1 by 2, 1 by 2 square. Okay. And this calculating you have to do correctly. Correctly means understanding. Your different type of solve, if going now, different solution coming. Maybe that is not a solution is there. Correctly common have to take correctly GP series, AP series have to change. I will do. You first write. I have no place. This type question must asking on exam. And this type question you can get every places. Any book, BSc, MSc, Riemann integration book, always you will get. GP series coming now. Common rest will be 1 by 2 square. Till infinite addition is a by 1 minus r. Two by 3. So Riemann integration will be 2 by 3.
கொஞ்சோண்டு இதை மட்டும் எழுதிக்கிறது இல்லாட்ட அழிச்சு வரும் 1 செகண்ட் ஆகும். அதுவே விட்டு விட்டு எடுக்கு எரிச்சலா வருது. அவர் அப்படியே நிக்காரு பாரு. ஆக்சுவலா ஒரு நடந்துட்டு இருப்பாரு. அது എന്താ நெட்டு
Sir, I understood everything. On this formula based question more based. Okay, means series form they will give and they will find solution. So that series you have to prepare like that structure, and you can replace 1 by n plus dx, r by n plus x, and this limit and test infinity summation plus 0 to 1. Summation r will be 0 to n or 1 to n, anything possibility. Sometime n minus 1, 0 to n minus 1, like that also possibility. Some question giving that and all. Try now itself something, try, otherwise later also can do. Very important these questions and all. Always I am giving in class and February exam. Direct this question asking. Feb 2022. Alpha form they are asking. Power alpha. Direct came on exam hall. Just you have to prepare like that and have to solve. Some question now try and remaining homework. What to go? Can solve or anyone I will do. First time doing try everything. Not coming, send me. But very easy. Just you have to learn how to change on structure. F of r by n, 1 by n. First you see you have to change on n square. No. structure when came hereafter target R by N form. Okay, so N cube will come common, then 1 by R by N will happen. Automatic 1 by N we will get. Okay, so direct we will write hereafter. This by N will replace dx. This will replace integration 0 to 1. This is 1 by 0 to 1, 1 by 1 plus x whole cube dx. What is the integration of this? Minus 3 plus 1 by minus 3 plus 1 means 1 by 2, 1 plus x whole square, correct? 0 to 1. Minus 2 will come, okay. 1, 4, 2 square, 4, 0, 1 minute. Minus 1 by 2 common means 1 by 4, correct? Minus 1. So what will come? Minus 3 by 4, minus 1 by 2 into minus 3 by 4. So 3 by 8. Answer. Class. Understood or not? There, Yalini, understood. So just you have to prepare till here. This is structure got. After that, no problem. Everything you have to do like this. This understanding, no, how coming? R by N plus X, 1 by N replacing dx, limit and summation replacing integration 0 to 1. Only 0 to 1, not other interval. Problem here. Last. Second last. This question. What problem? You go 1 by n, n plus 1 till 2n, again 2n plus 1, 2n plus 2 till 3n. Here twice series will come. Twice like that will come. Limit. Sir, 0 to n, again 1 to n will go. I think next will come 2n plus r. Here will come n plus r, another 2n plus r. In that you write r equal to 1 to n, and before that r equal to 0 to n. 0 to n plus r will go, no? Here 0 have. So 0 to n. Again 1 to n. And same formula use. Any problem? You see there 1 by 8. Oh, okay, okay. One, I did mistake. N square we have to do. N cube will come. Have to write. That is print mistake. Clear or not there? What answer coming for this? This you did no. Log 3 coming. Okay, correct. This will come. Log 3 will come. This is log 2 will come. While morning class don't one. I listen. Go. Everybody try letter homework. Not coming, send me. I will send in group. Otherwise, group discussion do. Not coming, then I will send in group. Okay. Everybody online student, if solution not coming, anybody put in group. Nobody will give. I will give.
Sir,
Ah,
sir, in this example, if we get summation k is from 0 to 2n or 3n, then how we can do?
0 to 2 and don't write. This may be telling that log 3 that you partition to till n plus n. After that 2n plus 1, 2n plus 2, 2 summation you create there.
Okay, sir.
Ah. Try, if not coming means send me, I will send. But first try. Only you have to set on that formula. Improper integral is very easy and little topic. This is not big topic. Finished, everybody? So improper integral, two types you have to find. From finite integral. Finite integral means your lower limit, upper limit will be finite. That is called a finite integral. When limit will be infinite any one place, that is called an infinite integral. So on finite integral, if any one limit point, either A or B, are called infinite discontinuity point. Infinite discontinuity point means x tends to A or x tends to B, or both limit does not exist will come. Plus infinity, minus infinity, like that. So that is called the infinite discontinuity points. If infinite discontinuity points you are getting, then that is called a improper integral, otherwise proper integral. Proper integral only possibility for this, because whenever infinite integral will happen, infinite integrals are always improper integral. So proper integral means your limit will be A to B, finite integral, and no infinite discontinuity point. Okay. This is just a normal integration type. If question also asking your 11 class 12 type integration to finite value coming means convergent, infinite value coming means divergent. Okay, but theoretical more asking theories we will see. Next we will see comparison test. That finished? No. Right. Please don't write. That finished means tell. Huh? This. Finish this side. Same you write for B. This understood, no? What happening here? Fx means A is infinite discontinuity point. On that infinite discontinuity point, limit extends to A, fx by gx. Finite value will come. But what is g of x? G of x we have to choose from f of x, and choose means g of x will be the multiple function type. Because of g of x only, f of x fail going. Limit extends to A. And g of x also limit extends to a fail will go. Like that, g of x have to choose from f of x. After that, integration fx and integration gx convergent divergent to each other. So fx they are asking only, so we will verify g of x. If this is convergent, this is convergent. If this is divergent, this is divergent. Value different. Convergent value, integration value different. Same right for b. If b is infinite discontinuity point. Everybody breakfast and all complete have no? Huh? No. 1 to 2. Complete have. Okay. No, from morning direct came Complete him is no problem. Not complete means 5-minute break can give. 5 minutes. Not doing. Complete. 5 minutes break one. Okay. When 1 minute. This right first. This I will finish. Little only have. Just 2-3 questions. After that 10 minutes break I will give. Not 5 minutes. Okay. Chandan sir giving no 10 minutes take break. Sir will start after 10 minutes. He used one dialogue. When limit will be infinite case, in that time limit extends to plus infinity, minus infinity, whatever given have, and fx by g of x we have to choose. We have to do L finite value will come. What is g of x? G of x have to choose from fx, but that given function f of x we will convert in 1 by x function form. Means we will take common cancellation, full function will be 1 by x form. So whatever common portion will come, that only g of x. And at infinity this will exist. After that same divergent convergent to each other, same case. Suppose plus minus infinity to plus infinity given have, then we have to partition have to do, and both have to apply. Minus infinity to suppose 1, again 1 to infinity, like that, and both have to apply. Another next, maybe whatever they are giving, suppose 1 to infinite they give, and 1 is infinite discontinuity point, then this also you have to apply for 1, but we have to do partition. 1 to infinite, 1 is infinite discontinuity point, so 1 to 2, 2 to infinite. So 1 to 2 case you have to apply this, and 2 to infinite case you have to apply this. That g of x choosing important. Here g of x is the multiple function of with f of x. But here g of x we have to convert first 1 by x function, after that common portion. Here here fail will go. So limit changing, g of x will change. Okay. Please have. Amuda, what writing? Not finished. That. Integration 0 to 1, 1 by x into x minus 2. This is convergent divergent. So this type of integration you did, 11, 12 class, partial fraction and all applying. So you can solve it. Normally convergent divergent asking. So direct formula use and solve. Finite value coming means convergent and infinite means divergent. But if theoretical, they will ask question, what is the infinite discontinuity point? What is g of x here? Integration g of x is convergent or not? Any theoretical, then by theories, we first you see this fx will be so 0 is infinite discontinuity point. G of x, what we will choose? Because of 1 by x, this fx fail going. So 1 by x itself a g of x. And g of x also extends to 0, fail have to go. I wrote no, extends to 0, g of x also fail. Okay, and it out. X minus 2, 0 extends to 0, fail will go. Extends to 2, fail will go. But 2 not have no here. Okay, we have to choose. I will choose. Suppose I will do here 2. Then 2 also infinite discontinuity point. When both cases will come, then we have to do partition. Like that. And I solving now for this I1. Suppose I1 I am solving. So I1 solving means 0 infinite discontinuity point. So g of x will be 1 by x. I2 means 2 will be the infinite discontinuity point. Here g of x will be 1 by x minus 2. Okay. So g of x changeable, always will change. So suppose I1 I am solving. Finish after. G of x will cancel, then 1 by x minus 2. So minus 1 by 2. Finite value. So integration 0 fx dx and integration 0 to 1 g of x dx are convergent or divergent together. Fx they are asking only, so g of x we will find. So g of x dx, what will happen? Log x, log 0 minus infinity fell, divergent. So I1 is divergent. So 0 to 1 fx dx divergent. I2 suppose you are going to solve I2 1 to 2. And any one divergent is fail only. This is divergent only. Both will be convergent, then that is a convergent. Suppose I2 solving means same only. Here g of x will be 1 by x minus 2. Same limit. One by 2 will come. log 1 minus 1 value will come. So modulus using means 0 only, but 2 minus 2 minus infinity will come. Anyhow, plus infinity divergent only. So integration 1 to 2 f of x dx means I2 also divergent. So finally given integral 0 to 2 fx dx divergent. Okay, right.
Sir, 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 log minus 1 is not defined, right?
Log minus 1 non-defined, but modulus you can use and 0 you can use. Leave it.
Okay.
Otherwise, there you write modulus of x minus 2 if you want to write about log 1. Because negative side undefined. No,
Okay.
you can go fail this integral without mod. Convergent coming here. Here g of x convergent have, so integration fx dx means given integral is convergent. Understanding, no? G of x, how choosing? This question can try. Any problem? Huh? Oh. No, no. Infinite integral have means this is improper integral. Improper integral may or may not be convergent. You have to verify next, no? Infinite discontinuity point only possible for finite limit point. Here one is a finite limit point. So suppose here 0 to infinity here, then 0 will fail. So 0 is infinite discontinuity point. Then you have to change partition 0 to 1, 1 to infinity. And 0 to 1 case g of x will be 1 by x. But 1 to infinity g of x will be 1 by x square. Okay. Finished. G of x what? Oh. Wait. Means x power 5 by 2, correct? And x square have, then what will happen? 5 by 2 minus 2. 1 by 2, correct. G of x will be 1 by root x, and x tends to infinity, g of x existing. integration 0 to infinity. To root x, no, integration minus 1 by 2 plus 1, 1 by 2 only. Down also 1 by 2, 2 root x will have. So infinite divergent coming. This is divergent. So like that question only, no other anything. Suppose here in this question 0 to infinity, suppose they will give. Here say 0 to infinity. So 0 will fail, no, this fx. So 0 is infinite discontinuity point. So first you have to change finite limit both side. Because if 0 is an infinite discontinuity point, then g of x will be different. And 1 to infinite g of x is different. So you can change 0 to 1. And 1 to infinity like this. So 1 to infinity here solving. G of x is 1 by x square. 0 to 1 case, in this case, g of x will be 1 by x. And this we saw convergent. So you can check if this is convergent, then given series on 0 to, sorry, integral 0 to infinite convergent. If this is divergent, means divergent. Understood? Again, tell which place? Or g of x is? No, whatever common portion have no 1 by x root x. Common we are choosing. That common portion you have to choose g of x, not this portion. Common portion. Okay, we will 10 minutes break. 11:30 coming, 11:40 I will start. Okay. Improper finish like that question only will come. Next chapter we will see hereafter. Okay. Mostly this theory not asking, normally integration asking. So find value, finite value coming, convergent not coming, divergent. Yes. Yes, I'm telling Subhas. Uh, you clean board after some time. They will write after that. Okay, 10 minutes time, see 11:30. 11:40 I will start. Hereafter we will see power series. So we saw about infinite series, correct? Infinite series is convergent, divergent. So power series also infinite series only, but can tell infinite series of function form means your series is convergent. So at which interval convergent and which interval divergent? Okay, we have to find domain hereafter. So infinite series of function form, that is called a power series. Hereafter, this power series will be the convergent, divergent at which interval when x have. So domain we can use. So which domain convergent, which domain not convergent, divergent, like that we have to discuss. We can write complete. This is function form f of x. Finished. So power series is summation n equal to 1 to infinity an of x function form. So any power series have that power series, if you are going to find at which domain D convergent have, that domain D, every interval have center radius, already I told. So here at which interval given power series is convergent, that interval center is called a center of convergence of given power series. Interval radius will be radius of convergent, and full interval is called a interval of convergence and a domain of convergence, like that. This is a generalized I wrote. Here two power series I am writing. This is a standard power series. Summation an x power n. This is a power series, and this power series, whatever domain of convergence will come, that domain center will be origin. 0. Okay. And an x minus a power n structure, if you will see, so whatever domain of convergence will come, that domain center will be a. But every time you can't get like this. This is two standard power series I am telling. Well defined have. For this domain of convergence center will be 0. For this domain of convergence center will be a. Either a is belongs to real, 0 or non-zero. But other, if accept these two other structure means we can't tell center what will happen. We have to solve and we have to verify. Okay. Outside. Hereafter we will see domain of convergence, by which formula we will find, and what is the structure of domain of convergence. Very important chapter. 2 to 3 question fix up. 2 to 3 why I am telling, because radius of convergence having complex analysis also, and same concept. When complex analysis I will teach this, and I won't teach again, just repetition type I will write, same everything. One question coming from here, same formula, same concept, everything. So one from real radius of convergence, one from complex. So 2 question minimum will. Any theoretical asking, that is different. For domain of convergence, we have to solve by D'Alembert ratio test and Cauchy root test. Mostly, if you will see in series power n and all have, then you can go by Cauchy. Answer will come because here power 1 by n have, n will cancel and we can find soon answer. But both will give answer, and we have to solve less than 1, less than 1. I find right because we are going to discuss about convergency points. If convergency points we can find means automatic divergence point and all we can find. So whatever we will solve and whatever we will get, that we will compare with less than 1 and we will solve, then x value whatever we will come, that and all convergent point. Okay, from there domain we can find. After solving, which type of structure will come, that we will see here. Like that structure, when you will solve less than 1 and all, I told, when you will solve your structure, either this type will come or this type will come. This type coming means center is 0, this type coming means center is a. Is anything, any real number? This r is just radius of convergence notation. If r equal to 0, if this r is 0, any one case, then is nowhere convergent. Your center is a. Suppose center is and radius is 0, means nowhere convergent only. No, we can't go next, only on center. If r is a finite value, r is infinite, f of x is everywhere convergent. This full r, either center 0 or non-zero. R is between 0 to infinity, anything, any finite, r negative not possible. Modulus have no, also radius, nothing, only. Same that only we have to solve after that. We can write here interval x means x belongs to minus r to r, and end points we have to check. X is equal to r put, minus r put, if which side convergent coming, close. Okay, right. Is everybody? So whatever power series we have, that power series domain of convergence we will find. So first attempt, our domain of convergence like this or like this will happen. This meaning by this just now I wrote correct. So by first solution, your domain of convergence is this or this. Anyone. Either center is 0 means that, non-zero means this. So whatever first attempt we are getting domain of convergence, our given power series must absolutely convergent on this interval. Endpoints we have to verify absolutely or conditionally. If endpoints absolutely coming means close we will put and absolutely we will tell. Conditionally have means only convergent we will tell. Absolutely not. But first attempt, whatever interval coming between them, any point you will put and convergent, convergent, absolutely convergent will come. No conditionally convergent. Hereafter question we will see. I'm not this what graph this is. Very good. I will do any question, very easy question, this and all, but very unique. I will do this, I will do, or this or that, or which question for you looking tough? For you everything tough only? Looking tough, I am telling.
Sir, I sent one question on your WhatsApp, sir.
What, Navindan?
I sent one question on your WhatsApp.
Your question later I will solve. You are old student. A new student can't solve this question itself. This is not radius of convergence question. You go by uniformly convergent concept. That question, well, Westra's Amen test apply. I will solve and I send in group. Okay, you try, but uh, okay. Here only modulus x coming. Okay, so we have to compare less than. Suppose after solving you will get something also. So less than one put, and whatever you are getting you put that side. So here direct mod x less than r is structure coming. So whatever here will come, that will be the radius of convergence. Okay, so r will be 1. Radius of convergence will be 1. So domain of convergence, this will be the first attempt domain of convergence, -1 to 1. In our given power series must be absolutely convergent. And next you have to verify at -1 at 1. I have no place here, I am doing. I think convergent only. N square is there. So at x is equal to 1, summation 1 by n square, this will be the convergent. And normally convergent, whatever coming, that is the absolutely only. Okay. And at x is equal to -1, alternating series will come, but positive term series is convergent. So this is absolutely convergent. So here complete interval absolutely convergent. Okay, here only convergent writing, but this is also absolutely. Positive term series convergent coming means that is absolutely only. So our given function means complete domain of convergence will be -1 to 1, both side close, and given function f of x is absolutely convergent on -1 to 1 close interval. If conditionally convergent coming any one side, then you tell only absolutely convergent on this -1 to 1. Okay. First answer I don't know. Endpoint you are telling. Then only -1 to 1 domain of convergence and absolutely convergent also. No, endpoints finished. Endpoints no convergency. But open interval convergent also, absolutely also. Navindan, your question I will solve and send. But you can try Westra's MN test. Little question try. If anybody not getting, tell me. Any problem coming? Not coming. Not coming. Why not coming? Try. Everybody try. Another inequation I will solve. Tell any question I will do. I will go next. Which question?
Sir, third one.
Puri Lama. Finished. Which question? First, third, second I did. Online somebody anything told? And -1 will do. Both side. Minus than 1 have to do. Then limit n tends to infinity an plus 1 of x by an x. Zero coming. So nowhere convergent. This is a very basic question. What happened? No problem. You can skip some amount or some radius of infinity coming. Any place wrong have factorial n by x power n. 0, 1, 2, how infinity calculating wrong? There are infinity error. That will come this side, no? 1 by infinity. This structure want. Here itself n coming infinity by writing. This portion you have to take 1 by then infinity then 0. In this one term, two term, if you are leaving also no problem. Radius of convergence same will come. Whatever you are getting extra this side, complete always this structure prepare mod x less than r or mod x minus a less than r. All calculating less than that portion that side you do. This side don't do anything. I will do another question. In this question, Cauchy root test can apply in this question. Already power n have. Limit n tends to infinity an of x power 1 by n. So nx power n 1 by n. This n cancel. Limit n tends to infinity modulus of this last also nowhere convergent coming. This radius of When your power series in product form or addition form, then radius of convergence you have to find both separate, and minimum radius of convergence will be the radius of convergence of sum or product of given power series. So one power series I gave, you can see this is the product of two power series. Here after separate fx gx radius r1 r2 find, minimum will be the radius of convergence. And both power n have, both places Cauchy root test you can apply. 1/2 will be the radius of convergence. Minimum. This question everybody try. 2 power series find and same type you do. Finished. What coming this? R1 root 3. R2. Okay. Then minimum will be 1. like that can prepare. Series. Huh? No problem. In series, one term, two term, if you are neglecting, no problem. Same answer, same sum of series, everything same will come. Minimum is no. 3 how will come. There one telling. Root 3 told. 3 only. Oh, means R1 is 3, R2 is 1. Then minimum is 1. Okay. Answer is 1 only. Whenever power n coming, no direct Cauchy root test apply. Soon answer will come. Huh? Radius of convergence, whenever we'll ask radius domain direct, you go by formula only, an plus 1 of x by nx, direct solve. But sometime they itself ask radius of convergence formula, or also you also can use radius of convergence formula direct, but only two cases. When your standard power series they will give. I told mod x less than r. This side what? That is the radius of this side, either zero center or non-zero center. If you are after solving anything you are getting here, that you put this side and solve, that will be the radius of convergence. But in these two cases, when standard an x power and an x minus a power n, in this two structure, radius of convergence, this formula direct you can use. This portion only that side solving, this side coming. This portion only that side solving, this side coming. So r equal to this formula you can use. Sometime radius of convergence, they are notation giving for limit superior. This same only this they will give this notation. So don't confuse. Radius is always how much we can go increasing. That is the meaning. Radius of convergence limit superior also we can tell. Okay. Want to give notation you can give, otherwise don't fix in mind. They will ask notation only superior notation giving. Superior take out. Maybe they will confuse you. Inferior also, no inferior, superior. Every places. Either you give here or don't give also, no problem, but don't get confused. Same we have to solve only. But radius is always limit superior. Sometimes they will give only function. Series type they won't give. They will give this itself. Function is 1 minus x, and they will tell find power series. Radius of convergence, power series by radius of convergence, radius, domain of convergence, they will tell to find about this function. So this function you have to change in binomial expression, good. Or sometimes they will give center also. If center is anything 1 by 2, 1 by 4, anything. Suppose only this center I am not defining, then what will happen? Why x minus 1, then minus common after the unnecessary action. 1 minus x put direct. That also can take, minus will come outside. That is no problem. Summation x power n. So I think this type series going on, an x power n I told. So an will be 1. So center will be 0. You can solve here after. Cauchy root test apply for domain of convergence. So radius of convergence will be 1, and a domain of convergence this will be the domain of convergence, and we can test endpoints. 1 summation 1 is divergent, summation minus 1 power n also divergent. So this will be the divergent domain of convergence. So finally, domain of convergence is this. If suppose they will define center 1 by 2. In center 1 by 2, we want power series. Means our power series structure will be x minus 1 by 2 power. Whatever center given, we will do. This will be the series. After the Csir text we can apply. Minus 2 outside have, no need to take that. Inside will take also same solution will. So no need to find this radius. What coming? 1/2. So radius of convergence will be 1/2. Center will be also 1/2 only. Domain of convergence you can find same type. Hmm. Any constant time? Hmm. Yes. No, you will do inside what will happen? -2 or 2 power n plus 1 only will happen. There 2 power n have 2 power n plus 1 will happen. 1 by n that tends to infinity, 0 will go. Then same that 2 only will come. You want to put out inside and solve, no problem. Okay. Huh? Try first, ma. Without try, don't tell. Two inside will go, then 2 power n plus 1 will happen. Correct. Then that place what will happen? N will cancel. Then 2 power 1 plus 1 by n will happen. The limit n tends to infinity, 2 power 1 only will come. 0. No problem. Doubt have put inside and solve. Finish. Pen and paper with you have. Finished. So any center they can give, whatever they are giving, just like that subtract addition to answer. No, Domain of convergence always x belongs to 1. Always minus a plus r to a plus r. That is the domain. Domain means x belongs to. But whatever domain will come, you see that center must be that 1 by 2 will come. Want to go outside? And then love, don't love. With mathematics love. No, that is not math love. No, I can understand. Your power series, if any power series given have, and radius of convergence, whatever you did, after first derivative to second derivative to third derivative to, radius of convergence will be same. No changes. Okay. Suppose I have a n x power n power series, and suppose r is a radius of convergence of equation first. So what will be the r? Correct? This or that Cauchy root test. So we have to find radius of convergence of first derivative or second derivative, whatever. First derivative we will do. F dash x. Correct? And x n minus 1. So suppose that this is a new series, summation b and x. Then for radius of convergence, what we have to do? You can see after solving this derivative, also same radius of convergence coming. This is that same r. And I solved this is for derivative function. So I can tell radius of convergence of f of x and f dash x are same. And this will continue, double derivative, third derivative, everything. Second, again derivative we do and try, same will come. Finish radius of convergence. Some question I'm giving that and all practice. Related radius of convergence, one extra concept have that I won't give now. I will give uniformly convergent chapter will finish after that. because uniform convergence have to use. Two, three extra question have that until I will write. Practice later. Power series finished, huh? Complete this. Practice in home and more question practice, huh? Every CSI or GATE exam, one question must have. Radius of convergence, domain of convergence. Question wrote everybody? Hereafter we will see uniform convergence. Uniform convergence, in this chapter we will see convergency of function only, but that function collection of sequence of function and collection of series of function. Just now series of function we saw power series. Power series convergency we saw. Can tell that power series is one method for finding any series of function convergency, and that method is uniform convergence method. That we will see last. So uniform convergence, how we saw continuity and uniform continuity difference. Like that convergence and uniform convergence different. Here also we have to see that collection of sequence of function is convergent at which interval. We have to approach till. Maybe by approaching fail also possibility, so not convergent, not uniformly convergent. We saw before, this is the sequence. One, yeah. And this is a sequence of numbers, real numbers. Okay. But suppose if I will give x by n, and here after n natural number I will put, then this is the sequence of function. Okay. So this is the difference. And about this we are going to discuss in uniform convergence chapter. If this is the sequence of numbers and this is convergent, converges to 0, any number. This is the collection of function, and this is convergent or not we have to verify, and converges to which point will come, that point is called a function. Because this is a collection of function, so converges to also any function only, no. This is the x by 2, x by 3, x by 4, x by 5. So like that infinite number of natural number if I will put, then this what will happen? Closer to 0. So this is also convergent, and convergence to our here limit point telling, here limit function tell, and that function is a 0 function. And function means constant function also possibility, non-constant function also possibility, means variable form. Suppose I will choose x plus 1 by n. So this is the collection of x plus 1, x plus 1 by 2, x plus 1 by 3, like that. So this where will converge? Converges to x. Our this function itself. Our x is any value. Suppose you want how to think about x. X is any interval. In this case, x everywhere. This side also will closer to 0 will go. Everywhere converges to 0. Full R minus infinity to infinity. This is our x function. This is our x function. This is x plus 1. X plus 1 by 2. So just x plus 1. Suppose that this is x plus 1. Just extra one value. Suppose x is equal to 1. So 1 plus 1 means 2 only. So whatever x point you are getting, suppose at 1 you are getting 1, then x plus 1 means at 1 point will come 2. So like that graph will increase. So this is the x plus 1. Hereafter our every points x and in between will come. Because this will decrease and will asymptotes will prepare with this x. Asymptotes means will mix, will lie on that curve. So what will happen? This is the x plus 1. Next, x plus 1 by 2. X plus 1 by 3. This is minus point, no? So like this will happen, this type. Understanding what I am doing? This type. This closer to this x, this closer to this portion, negative portion and all. So finally, in finite number of natural number when I will put, then our this is converges to this x. Understanding? So this is convergent and converges to f of x. And what is that f of x? X. Whatever interval means this you will get. If x value you will put, then x every value will cut. Means suppose your interval is 0 to 1. Natural number also you are putting. X value also you are putting. Then your x value will come between this to this. All x value will come. All 0 to 1, everything will come. Okay. X value still I am not putting. Your mind may be running x value will put means what will happen. I am putting only n value. I want to show you when we have n natural number I am putting here, then this is the sequence of numbers. So converges to any number only. But natural number I will put here or here, then this is a collection of function. And this collection of function is convergent, converges to any function, either constant function or non-constant function. But you see hereafter. Suppose x by n I choose. And hereafter x value I will put. Then what will happen? When x value I will put, then infinite number of sequence we will get. Correct or not? Here x is equal to 0 I will put, means one sequence is this. 0, 0, 0, 0, 0 by 1, 0 by 2, 0 by 3, 0 by 4, everything. X places 1 by 2 I will put. 1 by 3 I will put. 1 I have no place. Here I am writing. 1, same type 1 by 4 and like that. If last x is equal to 1 I will put, then 1 I will get. So whatever domain value given have, this is the domain, means x value. So x value we will put in collection of function. Then infinite number of sequence of numbers we will get. Correct. So every x value, when I put in this collection of function, then infinite number of sequences I got, and every infinite number of sequence, if convergent, if you are getting, then I can tell no, this collection of sequence of functions are convergent, point-wise convergent at every point on this interval. So that is called a point-wise convergent. You can see 0, 0, this is convergent, converges to 0, converges to 0, converges to 0, converges to 0, converges to 1. Understanding? So on this interval, this collection of sequence of function convergent have at every point. So this is called a point-wise convergent. Next concept, we will see on this complete closed interval 0 to 1, our limit points what we are getting. Limit point, every place is same have 1 means 1 by n. No. Sorry. I direct 1 I put. So here x plus 1 means 1 by n. So 0. So next we have to see if this is a point-wise convergent, then point-wise convergent converges to where? What is that our limit function here? Either limit function is a constant function or any function defining. Correct. So we can see our limit point are same 0, 0, 0, 0, 0, every places have. So here limit function is 0. So we can tell this sequence of function is a point-wise convergent on closed interval 0, 1 and converges to limit function is 0. So when we are getting this limit function fx, this is now here after on this complete interval. Now how I will write, you see, x by n converges to f of x. What is f of x? 0, where for all x belongs to 0, 1. This type I will write here after. So on complete interval, our limit point what getting? This function what have 0. Understood? Suppose sometime possibility have that our limit point different coming. Possibility have x value I put. Don't sleep. Time what? 1:33 only. 10 minutes have. Hungry coming. Don't sleep. Sleep coming little. 10 minutes I will live. After that eat and sleep. Let's click on class. Till here don't eat. So I was telling, when x value domain points 1 by 1 I am putting in x, possibility have no convergent but separate limit point, 0 getting 1 getting 2 getting 3 getting, like that possibility have. So when distinct limit points coming, then we have to see, we will tell no problem that our point wise convergent. If for at least one point, if divergent coming, then we will tell not point wise convergent on that interval. Whatever x value I will put here, every point convergent have to come. Then we will tell given collection of function point wise convergent on this interval. Understanding? If at least one point I am putting and not convergent coming, means no point wise convergent on this interval. Okay. If point wise convergent have, every point convergent have, limit point unique coming, then this type we can write. If limit point, suppose limit point, we have any function of x and our fx separate came. Suppose 0 coming, 1 coming, 2 coming, 3 coming, like that, increasing between whatever values is are there. So more than one limit point have. More than one limit point have on that interval. Sometime what will happen? Complete function form will come. That is different. What I am telling, try to understand. Suppose I will define, otherwise you will get confused. Suppose I wrote 0 to x less than 1 by 2. I got 0. 1 by 2 less than x less than 1 I got 1. And x is equal to 1, I am getting 2. Like that, suppose that, like that 3 types of limit coming, 0, 1, 2. Means on this sequence, x place between 0 to 1 by 2, anything putting 0, 0, 0, 0 you are getting. But again, between 1 by 2 to 1, you are putting then 1, 1, 1, 1, 1 getting. And x is equal to 1, 2 coming. So this complete, on complete interval function type, I can't write, no? Any function I can define this? This is x function or anything? Can't define any function, I can't define. Wait. Suppose, again I am writing another function, then you can understand. This fx, I am getting between 0 to x and 1, whatever value you are putting, same getting. Means I can write, no, x itself. 0 means 0, 1 means 1, 2 means 2. Whatever you are, 1 by 2 means 1 by 2, 1 by 3 means 1 by 3. So between 0 to 1, same to same if you are point getting, then meaning x itself, x function. And x is equal to 1 plus also 1 getting. So this is full x function only, no? So I am telling that I can't convert this is any function form, no? This is fx is equal to x. I can tell. I can't convert. Understanding what I am telling? I can't tell that between 0 to 1 by 2, 0, only 0, 0, 0, 0 going on. Between 1 by 2 to 1, 1, 1, 1, 1 going on. And between x is equal to 1, 2 have. I can't convert in any function form. If I can convert, suppose that I wrote, that is the x function. So x function is continuous only, no? So that is the one limit point. Full function is a limit point, but here limit point is not unique. On complete interval, 3 types of limit point define have. 3 types of limit point I am getting on complete interval, but that place you don't think that x is our complete limit point. Don't think they are also distinct have. That is distinct not. That distinct same to same coming only x function preparing. Understanding? So when x function coming, then that is a continuous function on complete interval 0, 1. But if this structure will come, then this is the discontinuous function. More than one limit point will define on complete interval. Of limit function f of x, I can tell, no, this is the discontinuous on closed interval 0, 1. But that is a continuous limit function on closed interval 0, 1. I can define. So discontinuous means more than one limit point on that complete interval. Continuous function means that is the full continuous limit function that is. Okay? Understood? And both case point-wise convergent, no problem. I can, this is the point-wise convergent, converges to discontinuous limit function. That is the point-wise convergent, converges to continuous limit function. Okay? Understood? Next, if point-wise convergent have and converges to discontinuous limit function getting, then direct tell never uniformly convergent possible, because uniformly convergent means we don't want any trouble problem, because our limit point itself undefined can't tell. I want uniformly means unique limit function, means our on complete interval unique way have to go, means continuous limit function. What discontinuous limit function means that is not possible for uniformly, because I can tell by our language on that domain limit function have more than one limit point, like that you tell. I can't change in function continuous function, so that is a more than one limit point, not a unique limit point, so uniformly convergent, finish. But continuous limit function if you are getting, then may or may not be uniformly convergent. We have to verify next. Maybe any place x I will approach anything and fail will go. Understanding? So if continuous limit function coming, then may or may not be uniformly convergent. Discontinuous limit function coming, direct without calculating, you write not uniformly convergent. No need to proceed anything. Okay. So this is roughly discussion. You can write also. Next definition and all I will write. Time also keep and all. After the definition I will write. Huh? This right, but this is just roughly discussion. Right, everybody. Right after that, after lunch, we will see. But this is not JAM syllabus. But in future, CSIR and I'll have to write must. That time I will use. But other university exam writing, no Pondicherry University or nowadays that CUET and all started, must will come. Except JAM, every places have. NBHM, TIFR. This is the graph of x plus 1 by n. That is the graph of x by n. You can write. This is the x plus 1 by n. This is the x by n. Finished everybody? Okay, after lunch.